Hey, everybody. Welcome back to another episode of the Ruby AI podcast. I'm one of your hosts today, Valentino Stoll, and I'm joined by my co-host, Joe.
I'm Joe Leo. I'm the other host. Hey, RubyConf is coming in July in Vegas. Valentino, Ben, will I see you there?
Probably not, sadly. As much as I love RubyConf, I'm not a huge fan of conferences in Vegas.
That is sad. On that note, we're going to introduce Ben Schofield. Thank you very much for joining us on the show. And sorry you don't love Vegas. I haven't been since I was in my 20s, so I'm looking forward to another chance to take a crack at it.
When RailsConf was in Vegas, when O'Reilly was still one of the partners, it was an experience. I do not think that it lent itself to the sorts of conversations that I find valuable at conferences. Having to walk through the casino floor to get to everybody else. There are great stories from that conference, but I like things a little bit more low-key. I think it's for a different sort of conference.
Well, that is an interesting point. That's funny to me to see it in Vegas. I mean, I know it's not the first time, but engineers in general typically prefer a lower key event. You get some good rates and good hotel in Vegas, and I guess it's easy to get everybody there.
So easy to get there. It is a central-ish location. I mean, it makes a lot of sense. Different strokes for different folks.
Yeah, last time I was there was probably when I was 16.
16.
I'm kind of glad that I couldn't touch any of the shiny objects, you know? It is definitely like the manufactured world. If AI had controls over the physical world, like I just imagine it would produce Vegas.
Yeah.
Maybe minus all the gambling, but yeah. Yes.
Gambling seems to be everywhere with prediction markets now, and I can't imagine that won't be making it into AI's training data.
Well, so we're really happy to have you on the show, Ben. Author and open source contributor, maintainer, and longtime Ruby enthusiast and contributor. We're going to give you the floor here. Can you tell us a little bit about what you're up to now? Because I know you've landed in a full-time role relatively recently, and the focus of your many various interests lies today.
Yeah. This is an aside that we'll absolutely want to cut out. Bento did layoffs at the beginning of the year and dropped 2/3 of the company. So Friday is actually my last day.
I'm sorry to hear that.
It happens, right? Well, AWS is apparently laying off 16,000 people today. So,
I was reading Bento and I was like, oh, this is a really cool service.
Yeah, I know. Me too.
Honestly, I have been so happy here. It is very hard to find a place where you feel like you're doing direct good in the world if you work in software. It was at GitHub, and we enabled a lot of people to do lots of good in the world, but we were still X steps removed. Here, like in November, as part of the government shutdown, we partnered with a nonprofit in California and fed 5,000 people with work that I was doing. I was writing code on Tuesday, and on Wednesday, meals were going out. But for various reasons, they laid off 2/3 of the entire company, including all of engineering leadership and all of us who had been hired most recently. So
aside,
around.
Yeah, well, true.
I think what I would love to talk about and where I'm coming from as I think about AI in general and to some extent AI with Ruby, I've been really fascinated by expertise forever. What does it mean to be good at the thing that you want to be able to do? What does it mean to be a world-class athlete or an international soloist in music or a chess grandmaster or a Nobel Prize winner? Like, what does that mean? How do you decide what to focus on? Because we are all finite beings and we have limited lifespans and we can't be the best at everything we possibly want to do. How do you choose the level of achievement or performance you want to attain? And then how do you get there as efficiently as possible? I know I've been speaking about this. I think the first talk I gave on this was an Ignite presentation at RailsConf maybe 12 or 13 years ago called How to Be Great by Someone Who's Very Much Not Great. And it sort of pulled in expertise research at the time. This was a little bit after Malcolm Gladwell's promotion of the 10,000 hour rule came out, which I think he talked about I think it was Outliers was the book.
That was also in Refactoring Your Wetware. That's where I read it.
Oh, was that Andy's book? Yeah. So Andy I don't know that he's written much recently, but he's also thought a lot about this or is at the time. And so I got really excited by that. The idea that you can be as good as you want to be at whatever you want to be at, regardless of sort of your initial talent with heavy quotations. And so I went and started diving into the primary research and reading Anders Ericsson and reading responses to him, some of which have come out more recently. And so my thinking on this has evolved. But I think what would be interesting to talk about with you all, and maybe I can ask you two a question, is the guiding principle of any discussion of expertise is it's domain specific. And the way I like to individuate domains is by identifying the goals and aims within that domain. So if I'm a 100-meter sprinter, then my goal is to cover 100 meters under human power as quickly as possible while generally racing against other people, right? Faster than my opponents. If my goal is chess, then my goal is to win games, and there are constraints and rules and things and measurements for that. What do you two think that the goals and aims of software development are?
Are we allowing our guests to ask us questions?
That's a great question. I feel like this is it depends answer. Software is constrained really by hardware in my eyes. We have like very hard constraints physically. And so like really software is whatever you want it to be on that hardware. So like if you're trying to build something, you maybe constrain it for your end audience, the people building it, and the performance or utility of it will reflect the decisions that you're talking about. And so we almost have these kind of like similar domain constraints that are coupled to the hardware, but also coupled to the people that are building the actual things and maintaining them. And I'm interested in, okay, well, what happens if we take out that maintenance burden and it is literally more of a passive thing? Because we're getting to this point where agents are evolving to a place and all of this AI is doing the software work and we are communicating the ideas and basically being that communication layer as far as translating the domains to it, and it can decide based on its constraints and the hardware it's using and the things that you're saying that you want to do with it. Hey, go build this thing and maintain it and service the end user, which is ultimately where we have been and we build teams around. I don't know what your thoughts are on that. That's where I see the industry moving.
Well, so is your point, Ben, in asking us this question that software engineering is not nearly so constrained as a 100-meter dash or a chess game, and we don't have a clear definition of what it means? My own thought, I mean, what I communicate to my engineers is that our goal with software engineering is to build sustainable systems, similar to what V is talking about, and to build something that is useful to humans at the end of the day. But of course, there's a very wide range, certainly wider range of outcomes than in a chess game.
I think those are both interesting takes, right? So for Valentino, I would back up a step and say, before we start worrying about the hardware, like, why are we writing the software? And I think that Joe answered that for one use case. That's not the only reason we write software, right? I remember the first computer I ever programmed on was an Apple IIe, I think. And maybe I checked out from the library, but I had a book of Apple basic code that I was typing in there. I wasn't trying to build a sustainable system for users, right? I was, to some extent, entertaining myself and making this complex machine do something that it couldn't already do, and exploring and doing it for the joy of it, right? So I think, Valentino, you originally said it's kind of an it depends case. I think that's absolutely right. There is not a single set of goals and aims for software development. We do it for different reasons. And I think that should inform how we think about where and when and why we bring in agentic coding or AI more broadly. Are either of you familiar with the philosopher C.T. Nguyen? He got some public acclaim a couple years ago. He's my favorite currently working living philosopher. He's a professor at the University of Utah. He was on the Ezra Klein show, and he's been in various public spaces for a couple different reasons. But a few years ago, he wrote a book called Games, Agency as Art, which is a book about the philosophy of games. And he identified two ways that people go about playing games. There are achievement players and there are striving players. Achievement players are in it to win, and striving players are in it to actually play the game. They get the value out of actually playing the game, not just from the outcome. And his example is he plays board games with his wife. If he were a purely achievement-driven player, then when he was not with his wife, he would research strategies on the internet to be able to beat her. But he doesn't do that because the value he's getting out of playing games with his wife is playing games with his wife, not out of beating her. And I think that that is a useful lens through which to view when we bring in agents to code, right? If my goal is the outcome, then I am perfectly happy to hand it off to a swarm of Claude code agents and have them build whatever and engage in the feedback loop and work on how well I specify the problems and get the outcome, right? Because I want the outcome. But that's not the only reason we code. Sometimes we code because we don't fully understand the problem and we work it out in our head and on the keyboard, and we set up test cases for ourselves. In the actual doing of it, we see how we want it to work. That's something that I think we'd miss if we just hand that piece off to the agent, because we'll be telling it to implement our mental model, but our mental model is incomplete. And so it's going to fill in the gaps with its training data or history or something else.
Yeah, I think that's absolutely right. I was doing this just yesterday when I was doing some upgrade. It was a simple upgrade of Ruby 3 to Ruby 4. And things were failing. And I was like, this is taking a long time. I can just give this to an agent and just have it fix everything. But I was curious about what was going wrong. Like, why is it failing? What are the bindings that are failing? Like, what's tripping? And that's an interesting thing that I think you'll probably take us into, because we are all not young on this podcast. And, we've got some experience. And so I think that's maybe we can kind of use our inner or just our learned judgment to say, well, this is something that I think I need to learn, or I just want to learn, and it will benefit me, versus this is not something I need to learn right now. I'm just going to move quickly, that the novice does not have.
Yeah, absolutely. And we've done this eternally, right? I do not know how DNS works. I have a high level understanding of how DNS works. I have a friend who runs a DNS company, and he knows at the very deep technical details how it works. I don't need to know that. I have chosen not to bring that to my attention. I am focused on a different set of problems. I could have focused on that, but I know other people are working on it. So it's not something that's in my head. I think when we are talking to agents, we need to be very intentional about what we put in their head, right? Context management is absolutely key, even as context windows get bigger and bigger, right? I don't want to shove the entire Encyclopedia Britannica into the context window because there's going to be a lot of extraneous stuff that's just going to confuse it. So there's a certain level of attention and intention that we need to use our experience and histories with to help the agents do the things that we need them to do, if that makes sense.
Yeah, it does. There was something that you said in your response just there that had me thinking. You are comfortable leaving the details of DNS to other experts and to potentially a machine, because you have done this study, and this kind of comes back to the 10,000 hours thing, right? If you had spent 500 of those hours learning DNS, it would actually be a distraction from your personal goal of learning, or just your personal fulfillment as a software engineer. I think that is, speaking from my own personal experience, a very difficult thing to do. It is very easy to say, but this could be important, but I might find this really interesting, or maybe this is the direction I need to go in, right? And so how do you limit those divergent paths? Because actually they come up all the time, every day.
Well, and they're infinite. There are always more levels you can dig into.
Maybe I do want to be a sprinter.
Well, and I think there are actual clear benefits to having a broad base of knowledge, right? So another book is the science and sports journalist David Epstein wrote a book called Range, which is, I think the subtitle is How Generalists Triumph in an Increasingly Specialized World, or something like that, where he contrasts the background of Roger Federer, who did a lot of different sports as a kid and then became one of the greatest tennis players of all time, and Tiger Woods, who famously was golf as soon as he could stand up. And some of the interesting research in talent development is that the highest performers as adults are generally not the people who specialized early and stayed specifically within their tiny rut all the way until they were 30 years old. There's a recent research paper by a collection of folks that is evaluating that, and they found the same thing, right? So there's actual scientific data as opposed to journalistic anecdata. Yeah, and so I think there are absolutely benefits to looking into the things that you don't know that you need. There's a metaphor I could go into that I will not, but I love it. That is pirates and Katamari Damacy. Maybe we'll come back to it later. I don't know. But the way I manage it is...
This is going to keep everybody on the episode till the end. This.
Will we get King of the Universe or King of all Cosmos by the end? I don't know. So the way I manage that problem is suboptimal. I don't know that anybody has the perfect solution, but I am generally working towards a goal, and I will keep an eye open to the things alongside that goal. So if I were just now learning how to write web apps, I would not worry about hardware design. Who am I kidding? I don't worry about hardware design now. I know that...
Me neither. I leave that to Valentino.
Yeah. So GPU architecture, vitally important. I am so glad that people are fascinated by that, but that is 5 steps removed from the problem I'm trying to solve right now. And I will look at the things that are 1 step and maybe 2 steps. And if I'm bored someday, maybe I'll be reading a history of Silicon Valley and I'll get really interested in the semiconductor industry, or actually I read the history of Bell Labs.
Yeah, that happened to me too.
Yeah. So I'll get a little bit about it there. And
but fortunately or unfortunately, I can only get so far before I'm just like, God, I'm so over my head. I can't even.
Well, and I think that's okay. So I'm not a huge fan. I recognize that there are individual differences that are sort of innate to people, but I think that the capacity for improvement across any domain is so much greater than we think it is. I will never be a world-class sprinter. I'll never play in the NBA. I could be a lot faster than I am now, a lot better at basketball than I am now if I chose to focus on that, but I don't have to choose to focus on that. I can't be the best I could possibly be at everything I could possibly do. So maybe I've just resigned myself to being mediocre and stuff. I think I wrote an article called In Praise of Mediocrity at one point. I think keep your eyes open for things. Don't ignore them, but you don't have to seek them out. There is so much wonder and fascinating information in the world that you're not missing out on the most wonderful thing. Like, you will find a most wonderful thing and be happy and be better at whatever you're trying to do. You just dig into anything and it's more fascinating than you could ever imagine.
You make a really interesting point here on domains and the importance of kind of cross-domain knowledge. And it makes me think of DHH's conceptual compression talk. And I mean, he's constantly talking about it. But it makes me think of 2 things. When we think about like designing systems for like stepping into we're designing to build software, domains are great because we make boundaries for them, right? Like, that's the whole purpose for making great software systems that work together in quality ways, is we can create the boundaries that make it easier to work within those specific cases. And it makes it easier to extract out and step back and make sense of those cross-domain things. And setting the boundaries is very important. And I feel like you're saying it's true of even like our own domains and our own domain knowledge. So I think about this idea of conceptual compression as like kind of making those boundaries and setting up the domains and making it easier to cross them. And what DHH is known for saying is how lossy that is and how that loss is okay. But what are your takeaways from a systems perspective with all of these agents? It's good to constrain them to domains, and that's kind of like how we're doing it with our software is, okay, we're creating a better focal point and setting these boundaries up. How does that loss affect things? And how do you think about the loss in those ways?
No, I think that's a really good point. When we make decisions, we can make them thinkingly or unthinkingly. So we can choose to say this is within our domain or this is not. And when we compress, we are making decisions about what we think is important and what is not. So I could have a compression algorithm that eliminates all white space. And that would be fine for JavaScript. It would be fine for Ruby. It would not be fine for languages that have significant white space. So the choice I'm making there is, so it defines the domain on which this will work, for one, and it sets some things aside. We talk about this in business with what is the core competency of your company, right? So if I work at Amazon's a really bad example because they've expanded so greatly, right? If I work at, Cloudflare, then I am not going to set up warehouses and start shipping hardware around. That's not my core competency. My core competency is in routing and caching and doing all the other like internet layer stuff. That's a choice. For Cloudflare, it's probably not an intentional choice to not have warehouses and ship a fleet of delivery vehicles. It's kind of an accidental one. But whenever we design our systems, choices are being made. We're making some of them are made by default. And I think this comes back to something we mentioned earlier, right? I would say to be the most successful user of agentic coding, you need to be as intentional about as many of the choices as you can, including the choices about what are intentional choices or not. So I'm choosing to give this set of agent.md files or expose this set of MCP servers or whatever it is. I'm choosing to let my agent know about the GitHub MCP because I want to use Git as my source control and I want to use GitHub as my sharing platform. I don't have to do that. It'll probably use that anyway. Maybe it's not a core concern of the system that it used in GitHub, but it's important for me for whatever reason. Maybe I work at Microsoft. So yeah, I think compression is really interesting as a tool for understanding because it forces you to decide what you care about. Compression is getting rid of the stuff you don't care about.
Valentino, this reminds me of our conversation from last week where you were talking about the GPT you created that was a software architect. The answers would change depending on what books you let it look at. I loved that example. And that sounds like a similar thing to what you're talking about here, Ben. We need to make an intentional choice about what we're supplying the agent with.
This makes me think about going back to the hardware. I don't want to harp on this too long. Basically, the constraints of the system. I remember hearing a talk at, honestly, like a local Ruby meetup. Somebody came on and talked about building systems for like Mars rover, as an example. You build that software much differently than you would, say, a web application, right? Because you literally have constraints with hardware and resources that you need to account for. And so like you're more critical of the choices that you're making, maybe the language preferences even, because it is so crucial to get like the most optimal use of those resources because you are constrained by like how much time you have to use them even. And so like I think about other constraints like that. Most everybody is building on the web, but that's not where everybody's building. And so I think about how those constraints maybe like affect software in general. I'm curious, like, where do you see like constraints servicing and how are you maybe approaching them differently depending on those cases?
Yeah, that's an interesting question. Before I answer it, and hopefully I won't completely forget it, is my favorite example of this is software for like satellites and probes that go out apparently has to be resilient to memory locations being affected by like cosmic radiation. Like a particle comes out that hits,
I didn't think about that.
Flips. And that is a constraint I have never and will never have to worry about.
Thank God.
Yeah, I was reading a terrible sci-fi thing and they were taking equipment into a zone where everything had to have like 8 different levels of backup because the environment itself was gumming up the works so continuously. And that's a level of resiliency I don't need in anything I do. I'm not building software for heart monitors. I'm building software that makes money, and that's important. Like, I'm not going to crash an economy. I'm not going to kill anybody. Fingers crossed. Yeah, so let me try to answer your question. You can tell me if I've failed or not by shifting a little bit. And instead of constraints, I want to talk about defaults. The favorite question I started asking when I was interviewing for Staff Plus engineers in the past is, what is your default? If I ask you to build a system and I give you some specifications for it, you are going to make it either more secure or more scalable or more performant or more modifiable or something else. Your history has led you to a point where you know in your heart that people always underspecify how X it needs to be. And so you're going to make it more X just by default. I love that question because the answers I got back were so different from different people. And it informs whether you need to hire that person. Because if I'm trying to fill a gap on my team on security, I will want someone more if their default is security, if making things more secure, or less prone to abuse and harassment for our users or something like that, right? People have all kinds of different defaults. And this ties back into Joe, what you were talking about, Valentino, with the software architecture GPT, is being aware of your defaults is almost more important than like getting rid of them or changing them, because you can shore yourself up with other people who have different defaults, or maybe custom subagents who, like, security is not my thing. I can do security, like all the basics, and I know OWASP and all that, and I know what to run, but my default is not making things more secure. So I can have a subagent going behind me and saying, hey, this might be vulnerable to some sort of, maybe a prompt injection. I don't know. I don't know that anybody has a solution for prompt injections right now, but it'd be great if they did. Does that sort of start to talk about what you wanted to talk about?
I think so. I mean, I do see this personally too in my own development, because I have wide range of interests and I'm all over the place. And it's very helpful, to be honest, all of this AI, because I can experiment in different ways. And like you said, set up different defaults for those varied use cases. And I do. I have very wildly different Claude files or other agents that work better in very specific use cases, different domains. As an example, like doing hardware stuff, I like to tinker and like make new things, and I just have components, and it's more of like image related activities where I'm taking pictures of components and saying, how can I use these things and connect them to make something, right? And so the overall experience with that is much different than it would be like poking around on a website or something. Yeah, it's interesting to think about the defaults in these different ways. And something I think about related to this is how the defaults might affect the power of these things or manipulate them in ways that prevent them from doing things without all of the defaults. Right. And I'm curious what you think about this, where let's say you just install Claude for the first time and you're just using it. And on your own machine, you have like all these defaults that make it use in specific ways. Are you missing out on things that come from the general purpose? And how do we measure that? How do we know? I worry about this, like maybe, the side effects of the defaults negatively impacting us, right? How do we even know that that's happening?
I think this goes to Joe's question about how do you decide what to pay attention to outside of what you identify as your core domain. Maybe knowing about DNS would make me an infinitely better web programmer. I don't know. And this has always been true. Like, AI doesn't make this worse. I have a .files repo that lets me set up a new computer. There are so many different ways you could set up your .files that my defaults work for me. There might be something that works 10 or 50% better. I don't know. It's a weird example because part of the value is actually the familiarity with it. And so it's hard for me to see what would actually be a 50% better .file setup than the one I have now. I can see incremental improvements, but like not a step change, right? One of the things I'm excited about with generative AI and code is it lowers the barrier to experimenting to find out if there are other sets that would work better. So I haven't done this largely. I've done it in the small, right? But I would love to see people, instead of generating one output from code, generate 5. One's in a different language. One's using a different framework. One uses a completely, like, these patterns are banned. These patterns are required. And just see if and I think you talked about this with Chad Fowler, the importance of sort of evals and specifications for judging the correctness of the generated code. And I know he's been writing about it on his leaflet publication with the Phoenix architecture stuff. Some things we care about. There are lots of different ways to accomplish the things we care about. Generated code makes it much cheaper to try to achieve those things in a lot of different ways and then pick between them. And that will then go inform our spec. So I generate 3 different solutions for this website and I'm playing with them, and performance was not one of my requirements, but one of them is dog slow and one of them is actually too fast. Then I'm going to put the performance requirements of that middle Goldilocks one back into my spec and do it again. One of my favorite quotes of all time is, how do I know what I think until I see what I say? And there's which I like it for philosophical reasons about the lack of internal privileged access to our own mental states. But I think it's relevant here because how do I know what I care about until I see it in the world?
Schrodinger's thoughts, right?
A little bit, yeah.
I want to take us from here to a category that I think is near and dear to your heart, which is, now that we're thinking deeply about all of these ways of making ourselves and the software that we produce better, for some definition of better, how do we bring that to the training of experts or the training of expertise in the engineers that we manage or that we lead? or that we just work alongside of? I think you've done some thinking about this, Ben, and I'd like to know what you think.
For a number of years, I have thought that the traditional breakdown of engineering career paths into manager and IC is insufficient. I think there are actually three paths. There's management, which is fairly well understood. There's super senior, deep IC within a specific narrow domain, working within that domain, and they can have incredibly deep expertise. I worked with like Git core contributors who are amazing. And then there are also staff plus engineers, which I think everyone has recognized there is a problem of vagueness around for ages. I think Will Larson and others have done really good work around, like, these are different archetypes of staff engineers or staff plus engineers. There's some secret component that is different from a super senior. They're literally different jobs. You can excel at one and not excel at the other, either direction.
Can you describe the basic tenets of what the differences are there?
The core for me is that a staff engineer works broadly. So they're talking to people outside of their specific team. You're more likely to get them in. So in a big company, like a platform organization where they have to talk to all the people who are implementing their or using their tools. Whereas a deep super senior IC, they might not talk to other people outside their team very often at all.
Yeah,
they are
better that way.
I think
Super senior, yeah.
one is externally focused and one's internally focused. Again, I think it's very vague and squishy.
I think that's true. I wanted to zero in on it because a staff engineer is a title that everybody kind of recognizes, and super senior is not. But I think people know what you're talking about and can think of an example of like, oh yeah, I knew this brilliant guy and he was just, if you put him on this one type of problem, he was better than anybody. It was not even close, but you didn't really move that guy or that girl outside of that domain.
And there's value in both of them. We need both of those people or all those people. So if we acknowledge that there is this third career path, how do we train people into that third career path? We sort of know how to train managers, and maybe they start as engineers and we see they have more soft skills, in quotes, and then we lead them to the management books that we like and they become managers. We know how to train deep technical experts. Not everybody wants to be there, but we give them harder and harder problems within their domain. We don't ask them to talk to other people that much, maybe. I don't know. But how do we train staff? It feels like they spring fully formed from the head of the company somehow. And every company treats them a little bit differently and promotes them a little differently and identifies them a little differently. So as long as I've had this 3-part career path model, I have thought that the best training for being a staff engineer is being a very early employee at a very small startup, because you're forced to work across the teams.
Well, I say just fire them all. Just get a bunch of experts and don't let any engineers talk to anybody. We don't want to talk to you anyway. Yeah. So what do you think? So you've got RubyConf. What else do you have your eye on this year?
I'm looking to join more of these Ruby AI meetups in New York.
Oh, in New York? Yeah. Next one's in February.
I've been missing them for a bit, and I've been experimenting just so much. We could talk about this later, but I have this project I started called Chaos to the Rescue. And it makes use of method missing to implement methods on the fly and redefine them at runtime.
I remember there being an experiment like this in a book that I'd read like a million years ago, pre-AI. But okay, so continue.
So I made this special console, and you boot it up and it loads and sets everything to auto by default. So it just automatically defines methods that are not there. And I start off with just like a class. It's just like a shell class called calculator. And so I say, okay, calculator.new, add 5 and 2. And the method doesn't exist. But because this module is included, responds to a method, it actually returns true to everything. So
that's what I was curious about. This, so does it go and then define the method and then...
Yeah. So it'll go and it'll intercept it in method missing and be like, Ruby will say it doesn't exist, and it'll pass that to the LLM and be like, okay, here's the class calculator, and it's being asked to call this method with these arguments. What, define it. And so it goes and it generates the code for the method, and then it uses define method and it literally adds the method to the class at runtime and executes it. And it works.
That's great. You got to present on that.
Yeah, I got to do that. I even hooked it up to Rails because they have a rescue from method. And so I just have it in Rails. And anytime, an error happens, it rescues it in Rails and redefines what it should exist. And so I'm going to experiment and see, how far could I go with a Rails app if nothing exists and it's rescuing everything and defining it at runtime? Like, how far will it get? Yeah.
Is the new experiment that Valentino's building.
I actually wrote a plugin way back in the day. The idea was if you ever got an unhandled exception in staging or development, it would automatically write a test for you with the path that you were on and the parameters and just drop that test in your test suite. And then you could go and make it pass.
I feel like I've used something like that. Maybe it was yours.
It was not mine.
It was not yours? Oh, yeah. Yeah.
My open source success was very limited.
We've still got a bit of time, and you were on a tear and you were talking us through the staff engineering model. There's no sort of model for, I think the last thing I heard you say was that the staff engineers appear to just come like fully formed from the mind of the company.
Yeah, we don't have a way of training staff engineers. And part of that is because we're really bad at defining what a staff engineer is, as I think we just talked about. And it looks very different between different companies. So as I've thought about this, and the people I've seen sort of be most ready to be staff engineers at big companies are those who were very early employees at very small startups that did not immediately die, right? So as a very early stage engineer at a very early stage company, you are forced to work across, not just deep. You can go to work for IBM right out of college and go incredibly deep and never have to talk to another soul except for your manager ever again. You can't do that if you're a 3-person company. That survives. I should be very clear. That survives.
That survives. Yeah, no, that's absolutely true. I think, Ben, the first time you and I crossed paths was when you were at Living Social, which was a startup that didn't die. And you had to wear a lot of hats to get that thing off the ground and running.
I would say I didn't. So I joined Living Social early, but not incredibly early, right? So I interviewed in still this crappy office building, but a month after I started, they had a building that was an old refurbished bank 2 blocks away from the White House or whatever. Living Social was a crazy experience, but particularly the reason I don't think that this super applies to me is because when I got to Living Social on the second day, maybe, they handed me the keys to email and said, here, you own this. And I did not have the luxury of doing anything else because Living Social was an email business. And I say that I've never written code where people died or you wrecked the economy. That was the scale at which I had never worked before. And a lot of people hadn't worked before. We were sending more email than mail service providers on a monthly basis. It was ridiculous. So I was very focused there, but I did work with people who floated around more and got that sort of experience. But again, at a very, very small startup, you don't have the luxury of focusing. And so if you are to succeed in that role, you are doing at least one of the skills that a really great staff plus engineer needs, which is communicating. Maybe another is figuring out with limited context, and maybe that's a big C context, I don't know, what you're trying to accomplish and how to make sure that everybody you're working with is on the same page for that. And I think that that is a skill that is separable from being an early stage engineer at a company, and is one that you might be able to train by working with agents, because agents are dumb. They only know what you tell them and what they trained on, which granted is the entire internet, but still they only know what you tell them to focus on to some approximation. And if you can get good at managing the context for each of them and specifying what you're actually trying to accomplish, you're going to get much better results than if you don't get good at that. Yeah, I've mentored people, and folks I've mentored to staff roles have said that the most valuable question that I taught them to ask was, what are we actually trying to accomplish here? If you can answer that for the agent, you're going to get a better result.
So what about the leadership skills that are also required, that are similar but maybe slightly different than managerial skills that the staff engineer inevitably needs to be successful?
I don't think you get those by talking to agents, sadly. I think not every training path will develop every skill that you need to be successful. But I think it's better to be able to identify certain skills that you'll need and be able to train those, and then you can look elsewhere for the other ones. So I think the management track has some decent leadership skill training. I think talking to people with more power than you in your situation and figuring out how to get them to do the things that you think need to be done. That's the core leadership skill I think that 7-years need, because 7-years generally have very little actual power. It's all influence instead. And for that, like reading things like Robert Cialdini's Persuasion and reading psychology, like this is a place where you should branch out. If you want to be a self-less engineer, you should be reading in psychology and in motivation and in leadership texts and biographies of great leaders. I think there's a lot to learn there. I don't think working with agents is going to get you leadership skills.
The specific learning, training, it makes me think a lot about what is missing from this whole industry, really, right? And I feel like I keep seeing a lot of like, you're giving the knives, box full of knives, basically, with a whole bunch of other useful stuff in there. And, you know, you're saying, okay, hey, go use this thing. And like, they go to reach in and like, obviously they're going to get cut, right? Everybody else knows there's knives in there and they just like can move around them. And I feel like what is missing really is like layering, right? Like we're missing this, okay, you're going to use this thing in this specific way because you don't know how to use it. And maybe this is a learning mode. Maybe there are modes or restricted knowledge or things like this. And the more that you use it, the more that you get exposed to because you know about that foundation. And I feel like this is what has been missed from software in general, is like you have these boot camps and they're like, all right, go build a web app because that's what everybody builds and that's what you're getting trained for. And you go and you learn how to do it, but really you're missing all that foundational stuff that maybe more traditional like computer science programs set you up to maybe learn better. I don't know if that's better, but just differently, all the same. You get like a base shared knowledge that can compound, right? And going back to like the folks at Every, they're doing this compounding engineering. It almost seems to like be a recurring theme too in the industry of, as you start to compound your learning, the past learnings then start to build on those additional ones. And so how can we start to set these tracks up in different ways? If you're trying to get to a staff level engineer and you're senior, like there are some clear paths there, but there are also a lot of non-ones. And really depending on your domain of expertise, like that could be different as well. What are your ideas in this kind of realm of like layered adoption? Like I think about like the Unix philosophy of like small tools that work together and can compound to create better tools. Are we following that path or is this completely new territory? What do you think about this kind of thing?
I think that is an active area of research in the skill acquisition and expertise development domains in academia. How much skill decomposition makes sense? And there are people who say that none, like the absolute best way to learn soccer is to play small-sided games with manipulated rules that cause the player's attention to focus on different things, or train a pitcher with a slightly heavier ball or a slightly lighter ball, or different constraints that lead them to, I don't want to get too deep into the technical weeds, but they lead them to figure out how to solve unexpected problems on their own. So it's essentially teaching them how to learn how to solve motor problems, as opposed to teaching them a specific solution. I think most domains, software development included, don't do a great job of this. I think computer science is great for learning computer science skills. I don't actually know that it makes you that significantly better at being a software developer in today's world working on a web app. There are things that are absolutely useful, but there are things that are not useful for that too. It is an unsolved problem as to what the skills that you need are. And partly because there's not a single answer to what are the goals of software development. There's not a single set of skills that's useful for it, right? You can be the best basketball player in the world and not be as good a center as Shaquille O'Neal, or as good a point guard as Steve Kerr, or there are lots of different ways to be good at software development, which means there's not a single set of skills that'll get you there. And so to some extent, your exploration and your development has to be guided by what you care about and what sorts of things you want to do and what you want to accomplish with software. But that said, I think one of the things, and maybe agentic AI helps with this, is lowering the bar to experimentation, increasing the feedback loop on seeing more fleshed out examples. So when I was coming up and when you guys were coming up, we'd work at a couple of big companies and see a couple of ways of doing big company architecture or something. Now I can have Claude generate, again, like 5 different examples in an afternoon, and I can look at them and see how they differ. And to some extent, the most successful theory of learning across like these wicked domains where the feedback loops are not clear, like the inputs and outputs, the relationships are not very clear, is looking at examples and identifying not specific patterns, but like patterns of patterns, that these are some of the things that can vary and still get you to the goal. And getting more examples of that, I think, is going to help train engineers faster than anything else that we have currently.
I like that theory. The thing that sticks out to me, though, is that the difference between the architecture I was exposed to at my first or second job and the architecture that an AI-generated example can expose me to is that the first one I needed, like there was immediacy to that. I needed to understand it to keep my job and to do well. And I had this drive to do well. And I think unless we bring that same sort of immediacy, I'm not saying it's got to be like you're fired if you don't understand it, but unless we bring this stuff into something that is critical path for the organization that the person is a part of, the aspiring engineer is a part of, then it becomes, like an exercise for the reader. And I think it loses that impact that it had by necessity.
Yeah, absolutely. One of the problems I've always had with learning a new language or a new framework or whatever is I don't actually need anything right now. And so if I start doing a toy version of it, it's a toy version of it and it doesn't tell me all the things I need to know. There was a talk I wanted to give for a few years and never got around to submitting anywhere called The Best Code I Ever Wrote, where the twist was that code never went to production. It was when I worked at actually Chad Feller. I worked with Chad at Zex Wunderkinder, and I wrote the message bus. I think he talked about the architecture like it was super, super microserviced. So I wrote essentially the routing layer for those microservices. And I wrote it in Ruby, and it was beautiful, and you could read it and you knew exactly what it was doing and had to change it. You knew exactly where it went. I love that code so much. And I ran it and it was dog slow. So I rewrote it in Clojure and it was amazing. Still, it ran for like years and years after I left, even after the Microsoft acquisition. It was great. You're absolutely right. Having an actual need is infinitely better at driving actual development of understanding and exploring all the things you need to find. I think there's a little bit of a double-edged sword in that sometimes you'll stop once you've solved that need and you won't go further. And so you won't find the dusty little corners that have things that will bite you later. But yeah, finding an actual need is like pouring rocket fuel into your learning.
Now, that said, there's the story of fighter pilot training, right? And they go into these simulators that everybody knows is not going to kill them. And they go in there for like 2 hours. They come out drenched in sweat. Their adrenaline like jacked up to here. So whatever they've been able to do, the instructors have been able to put their trainees into a situation where, yes, it's not life or death, but they can suspend their disbelief enough to sort of act as if. And then I think I am assuming the training is a lot better because you feel like your life depends on it. Now, going back to, I've never written any code where anybody's life depended on it either, but I certainly have written things where I felt like, man, I really better get this right. And I think that I'm just using personal experience. That has helped me to feel like, whether it is for the respect of my peers or the satisfaction of a job well done, that kind of an experience mattered to me in how much I learned.
Absolutely. I think this kind of gets back to the striving achievement play before, right? So if you're purely achievement motivated, you only care about the outcome. In those cases where you cared about the code, you were striving. You cared about the outcome, but there were also non-direct outcome things that you cared about that you were doing. I think figuring out how to put yourself into a striving mindset for this learning session that you're going to go on, where maybe you prompt Claude to generate a bunch of different examples, maybe that's the key, right? Instead of having, I need a to-do app, maybe it's, I really need to understand how this ORM works. And so I want to see like 5 different examples of how it works, because people have done forcing functions of submitting a talk on a topic and using that to force them to learn the thing. You can make up your own things that you have to accomplish out of learning. Maybe you want to contribute to an open source library. And so you force yourself to learn the things at the level you need to do that.
It's funny because I'll start vibe engineering something and it might ask, hey, XYZ, what are you really trying to make out of this thing? I just don't have time for it. I just say, oh, whatever, just pick one of these things. And so, how do we take a step back from that? Are there like actual channels we can start to build to help train people better? Is this worth effort to focus on, to force people to think about and react to the things rather than just push past it and get to an end result? Because like right now, people just want to push a button and like keep hitting enter to see the result. And like, what's the force function to like skew that into a new shape, right?
The sad answer is there isn't one, right? The forcing function is for people to care about what they're doing for some reason. It's not like there is a single reason that would force everybody to care about it. I think it's perfectly fine to say, I don't actually care which of these 3 options you take, Claude Code, do one. As long as you are being honest about that and caring about some of the options. I hate authentication. I hate it. It's terrible. I've written it a bunch of times. Now I am perfectly happy with, give me the median devise implementation for my Rails app. Don't care. Do that. Or something else. I don't care. As long as it works, I don't care. But there are aspects of the user experience that I care a lot about. And so you either give me options or I will then go in and hand edit. I'm not Gastown level 6 or whatever, where it's like never look at the code at all. The forcing function is deciding what you care about and then caring about that. There are lots of posts on doing the thing is doing the thing and not doing the thing is not doing the thing. They're going around various places. My overall advice is be intentional about what you're doing. Say you're going to be intentional about it and then actually be intentional about it. That's the forcing function to get you to care about the things that you want to care about. There's no shortcut. There's no magic.
Intention engineering.
Yeah, no.
It makes me think like of the old like Microsoft DOS games where they're like choose your own adventure, but like it's very specific. At this point, you can use one of these things. Oh, you don't know how to use it, right? And so like you have to like pick the right thing in order to know that you can use it, and then you can use it. And I wonder if like we're kind of experiencing the same thing, right? Like, should we be prompting people if I want to make a to-do app, and they're like, okay, what do you know about web apps? Right? And if the answer is forget about it or no, or like, I don't know, it steps into a new layer of, okay, well, what do you know about the routing layer? And like the more that you like enrich it, then it gives you the more permissible next step of, okay, yeah, we'll just build this thing. Maybe that's what we are missing is like intention gathering and skill acceptance. Okay, this person knows this skill, like we're going to skip all these other steps because they don't need to learn about it or understand, right?
150%. I want to make a to-do app. Why? What's your goal? Is your goal to explore how this new front-end framework works? Cool. I will use bog standard to-do backend database model. I am unhappy with how Notion allows me to classify things and subclassify them. Cool. We'll talk about the database schema. I think making our agents aware of our intentions, which requires us to be aware of our intentions. I guess that gets back to my, I don't think I have privileged access to my internal mental states thing from before. That's hard, but it is absolutely key.
I hope somebody builds an intention-driven Claude that forces that all kinds of stuff, right? I just want to use the tools. I don't want to build them in that way. I hope somebody is listening out there and the next day I just oh, hey, look at this new thing, that sounds like what I was talking about. Yeah. You never know. But I work at a big organization at Gusto, and we have a lot of these similar challenges of training and adoption of AI tooling and all these things. And how do you get people to use them the right ways and, varying, levels of expertise? How do you get everybody onboarded in a similar but different way to make the most use of the tools? And it's a challenge and not one that's solved easily. If you're out there and you have solutions, keep trying because it isn't there yet, or I haven't seen it.
We're way over time. I don't know if we want to wrap here. We'd love to bring you back, Ben, and continue to follow this thread. I think that people that are listening to the podcast, aspiring engineers, people who have been in that staff role, people who want to be in that staff role, I think that and people who are training others in any capacity or just want the people around them to be constantly improving. I think there's a lot more to be learned, and I'd love to continue to keep talking about it with you.
Yeah, happy to chat whenever. Thank you guys for having me. This has been a great chat.
Yeah.
Yeah, thanks, Ben.
Thanks, everybody.